All right, let's go ahead and review the concept of zero and negative exponents. So first let's talk about zero exponents. We know that with a zero exponent, any non-zero number raised to the zero power equals 1. That's any non-zero number raised to the zero power equals 1. The reason why this isn't true for the number 0 is because 0 times anything equals 0. Okay, so when we say x to the 0 power equals 1, we're saying that x is not 0. Okay, the reason why that's true is when you take a number and you divide it by itself, you get 1. For example, 3 squared divided by 3 squared, well, we know that 3 squared is 9, so 9 over 9 equals 1. Okay, if we write that exponentially, 3 squared over 3 squared, well, exponentially, when we're dividing powers that have the same base, you subtract the exponents. So 2 minus 2 is 0. So exponentially, 3 squared divided by 3 squared is 3 to the 0 power. So then for that reason, 3 to the 0 power equals 1, because 3 to the 0 power represents a number being divided by itself. In this case, 3 squared divided by 3 squared. Okay, so that's a small explanation, a very simple explanation as to why any number to the 0 power equals 1. Then the negative exponents, what do negative exponents do? Well, negative exponents mean when you have a negative exponent, what that means is that you need to get the reciprocal of that term. So for example, x to the negative first power equals 1 over x to the first power, which can be simplified as 1 over x, because x to the first power and x are the same thing. So that negative on the exponent does not tell you that your answer is going to be negative. What it says is that you need to get the reciprocal. So the reciprocal of x to the negative first power is 1 over x to the first power. Might be easier to understand using actual numbers. If I say 5 squared, well, you know what 5 squared is. 5 squared is 25. So what's 5 to the negative second power? Well, 5 to the negative second power is the reciprocal of 5 to the second power. So I can write this as 1 over 5 to the second power, or just what's the reciprocal of 25? 1 over 25. So 5 to the second power is 25. And 5 to the negative second power is 1 over 25. Now let's go ahead and apply those ideas to these expressions that we need to simplify here. 6 examples that we can do together. So what you want to do is, go ahead and try to pause the video and answer the questions, and then unpause and see if I answer them the same way. See if you can get the questions right. So here we have 3 over 3 to the negative fourth power. Now, one way we want to view this about handling these negative exponents is to think about what happens when you take a fraction or a number and you find the reciprocal. If I take the fraction 3/4 and I get the reciprocal of 3/4, that is 4/3. Okay? Well, look at what happened when I did that, right? I took the fraction 3/4 and I flipped it. That's how we get the reciprocal. But look at what happened. 3 was on top. It was the numerator. And it moved to the bottom. It became the denominator. And 4 was on the bottom. It was a denominator, and it moved to the top and became the numerator. Okay? So essentially, when you get the reciprocal of a number, things change places. The top becomes the bottom becomes the top. So that's one way that we can handle these expressions that have negative exponents, is thinking about that. If you see a term with a negative exponent, then change its place. If it's on the bottom, move it to the top. If it's on the top, move it to the bottom. So for example here, I see that on the bottom here, I have a 3 to the negative fourth power. So this is a negative exponent. That means reciprocal. So I'm going to change places. It's on the bottom. So what I'm going to do is move it to the top. And when you move this exponent, the 3 to the negative fourth, when you move it, it loses the negative off the exponent. So it's going to come up here, and it's going to become 3 to the fourth power. It's kind of the same idea when we talked about solving equations. If you move a term from one side of an equation across the equal sign to the other side, it changes signs. Well, when you take a term that has a negative exponent and you perform the reciprocal, and you move it from the bottom to the top or the top to the bottom, you lose the negative off the exponent, okay? So now what's left here is, well, we have this 3. This 3 does not have a negative exponent on it, so it's going to stay on top. There's no reason for it to move, so it's going to stay here. So basically I have 3 to the 4th times 3. Now, does this 3 have an exponent? Yes, it does. When you don't see an exponent on a term, there's an invisible 1 there. It's important to make sure that you recognize that. And what's on the bottom of this fraction? Well, on the bottom of this fraction is a 1. So now I can evaluate 3 to the 4th power times 3 to the 3rd to 3 to the 1st power, because when we multiply powers that have the same base, you add the exponents. So basically I'm doing 4 plus 1 here, because 3 to the 4th times 3 to the 1st. I add these two exponents. 4 plus 1 is 5. So I have now, my answer is, or I have this simplified to 3 to the 5th power over 1. And I can evaluate 3 to the 5th power. I just multiply 3 times 3 times 3 times 3 times 3. And I get 243 over 1, which can be written in simplest form as 243. All right, let's take a look at this second example here. And one thing that's important to point out is exponents only affect what they're touching. So it's important to understand that this exponent of -2 is not going to have an effect on this negative sign here in front of this parentheses with a 7 in it, okay? Because this exponent -2 is only touching the parentheses with the 7 in it. So it's not going to affect the negative, it's only going to affect the 7, all right? So what does the negative on this exponent of -2 say? It says, hey, get the reciprocal of this number. Well, what's the reciprocal of 7? 1/7. So let's take a look at what that looks like. We're going to keep this negative here, and the reciprocal of 7 is 1/7. And then we don't just get rid of this 2, we have to keep it. So now this 2 is here next to the 7, but this time as a positive exponent of 2. Because again, once we perform the reciprocal, the negative goes away from the exponent, but the exponent stays. And again, I can evaluate 7 squared. 7 squared is 49. So my answer is -1 over 49. Okay, next example. We have here 3m to the -8th power and p to the 0 power. Remember we talked about seeing negative exponents and the need to move them, right? Well, so what if you're looking at something and it's not a fraction? Well, you can make anything as a fraction. If I have the whole number 7, I can turn that into a fraction and just put it over 1, correct? So I want to do the same thing with any terms. If I want to view this whole expression as a fraction, all I need to do is put it over 1. Okay? And that's going to help me, because if I need to move things around, then it helps me understand what I'm moving. So here, what's going to move? Well, I already circled the m to the -8th power, right? So this m to the -8th power is a negative exponent, so it needs to move from the top of the expression to the bottom. So it's going to come down here, and it's going to lose the negative, so it's going to be m to the 8th power. Then on the top, this 3, remember this 3 is not being affected by the -8. The -8 is only touching m. So 3 doesn't have a negative exponent, so it stays. Then over here, what is p to the 0 power? We're going to assume that p is not 0, okay? Because if p were 0, then all of this would be 0. And that wouldn't be any fun. So we're going to assume that p is not 0. So p is some other number. So any number that's not 0 to the 0 power equals 1. So this becomes 3 times 1. So we work this out. Well, obviously 3 times 1 is 3. So now our answer is 3 over m to the 8th power. Okay? Just 3 more examples. And yes, they're getting a little more complex, but the beauty of math is this. Once you know the steps don't change. The problem might get longer, the numbers might get larger, it might get higher in value, you might see more negatives, but the steps don't change. So you see a big problem like this, don't freak out. Think about what you know and perform the steps. So here, I know that if I have negative exponents, that I'm going to want to move them from the top to the bottom or the bottom to the top. So let's take a look at any negative exponents we might have here in the top of this expression. We have here k to the negative third. So it's going to move to the bottom. And it's going to lose the negative off the exponent. It's going to become k to the third power. Okay? Now, how about this negative 3? This negative 3 is going to stay. So negative 3 times, now this mn to the third power, that's a positive exponent, so that's not moving anywhere. But what I want to do is I want to distribute this exponent of 3 to each piece of this mn inside the parentheses. So I'm going to distribute the exponent of 3 to m, and I'm going to distribute it to n. So in other words, this looks like negative 3 times m to the third power times n to the third power. Then finally, I have this p to the negative 8. And this p to the negative 8 is in the bottom of this expression, so I need to move it to the top. And when I move it to the top, it becomes p to the 8th power. So all of this multiplies together up on top to become negative 3 m to the third, n to the third, p to the 8th over k to the third power. All right, 2 more examples, and then I need to go drink some water because my throat's getting dry. All right, so again, I see these negative exponents. I know that I'm going to need to have a fraction, so to help me envision this better, top and bottom, I'm just going to put a 1 under it, okay? And let's go ahead and move these. Who needs to move? Well, I have here this 8 to the negative 2 power and this r to the negative 5th power. So let's go ahead and move them. So 8 to the negative 2nd power is going to move to the bottom and become 8 to the 2nd power times r to the negative 5th power is going to move to the bottom and become r to the 5th power. How about q to the third? Well, q to the third is just going to stay on top because it doesn't have a negative exponent. And so, very simply, this is q to the third over, now what's 8 squared? Do I leave it as 8 squared? No, I can simplify that. I can evaluate that. 8 squared is 8 times 8, which is 64, times r to the 5th. So we get 64 r to the 5th as our answer. Okay, one more example. Okay, so this one's already written as a fraction. Let's go ahead and take a look at what needs to move. Okay, who needs to move from the top? Just one term. Y to the negative first. So y to the negative first, that's going to move to the bottom as y to the first power. Then how about 11x? 11x is going to stay. And what's z to the 0? Again, we're going to assume that z is a non-zero number. So z to 0 is 1. So this is 11x times 1. And then how about the bottom here? Well, the bottom here we have v to the negative third power. And so this now needs to move. We need to move it from the bottom to the top. And so v to the negative third power becomes v to the third power. Finally, on the bottom here, well, I don't need to write y to the first power. Y to the first power is just y, okay? And then 11x times 1 is 11x times v to the third is v to the third. So this basically just goes together, and then v to the third alphabetically comes before x, so I'm going to write it as 11 v to the third x. And this is our answer. Alrighty then, I hope that this helps you to understand working with 0 and negative exponents. Thank you.